Okay, we are going to do one more video on looping. This time it's going to be while loops. And while loops are a little bit different. They actually merge together the idea of a conditional statement and a for loop. So what a while loop does is it will only actually enter the loop if some condition is true. So for a real simple example, let's just say this. Let's say n is equal to 5. And a while loop would say while there's some condition on n. So while n is less than 10, sure, whatever. We're going to do something. So what this does is say, hey, if I see the word while, I'm going to check if that returns a true or a false. Now, in this case, when I send in a 5, it's going to return true. So I need it to do something. I'm going to print the n. And then what I'm going to do is I'm going to increment it plus equals 1. So if I send in a 5, 5 is less than 10, that's true. So since it's true, I'm going to come down here, I'm going to print it, so I'll see a 5. And then n will be replaced, oops, not equals plus, there we go. N will be replaced by 1 more than what it was before. So now it's a 6. Come back to here, is 6 less than 10? Yep, so print it. And then n will be replaced by 1 more than 6. Now it's a 7. And back to here is 7 less than 10. Yep, so print it. And it's going to do that until this turns into a false. So let's see what happens. 5, 6, 7, 8, 9. 9 got incremented to 10. 10 is not less than 10, so it exited the loop. And notice that I ended the loop simply by backing out of the indentation. So a while loop is kind of nice. It just says, hey, do this thing until some condition is met. And it may not actually be clear when the condition is met. So I'm going to say while n is less than 100, instead of incrementing this time, I'm going to start squaring things. Ooh, so now this is going to be interesting. So we're going to start with 2. And I'm going to say, okay, 2 is less than 100, print it. Now I'm going to replace n with 2 squared, so now it's 4. 4 is less than 100, so print it. And I'm going to replace the 4 with 4 squared, which is 16, and keep going. Pretty cool. Okay, let's do something a little bit more interesting. So we're going to build the Fibonacci numbers, and we're going to build up all the Fibonacci numbers that are less than 100. So a Fibonacci number, we know that those are, so the Fibonacci numbers are 1, 1, 2, 3. So I got 2 by doing 1 plus 1, 3 by doing 1 plus 2. The next one will be 2 plus 3, so 5. The next one would be 3 plus 5, so 8, etc. Oops. Okay, so there's my Fibonacci numbers. But I want to do this with a list. So my Fibonacci numbers, I'm going to just start with 1, 1, because that's all we need to build the whole thing. And now I'm going to say while I want the last one to be less than 1,000. So the last one in the list is less than 1,000. So this is now a check. I've got a list coming in. I'm going to say, hey, go to the last one. Is it less than 1,000? So 1 is less than 1,000. So first time through, it's going to do whatever I tell it to do here. So for the Fibonacci numbers, let's see here. I'm going to add on a new Fibonacci number. Well, if I want to add something onto a list, append, fib.append, boom. Now I need to add the previous 2. So fib of -2 plus fib of -1. I want the previous 2. -1 is the last term in the list. -2 is the second to last term. And now I'm going to leave the loop and say print fib. Let's see what it does. 1, 1, 2, 3, 5, 8, 13. Let's see, 21 is 13 plus 8. 34 is, hey, looks like it's doing it. Oh, but wait, the last one's more than 1,000. Why did that happen? Well, let's see here. Append, it built 610 plus 987. So it built that. So it put that in the list. Then it went up here and said, okay, is 1,597 less than 1,000? No, that came out to be false. So it left the loop and came down here. So really what I wanted was everything up to, but not including the last one. Okay, great. Okay, now a little bit of a challenge. Remember the collat sequence way back here? So it's right here, the collat sequence. This is the one where you give it a number, divide by 2 if it's even, or triple it and add 1 if it's odd. Well, a for loop didn't really make sense for that one, even though the if statement was nice. A for loop didn't really make sense because this sequence, as it turns out, will always end at 1. And once you hit 1, you will always recycle into this 421, 421, 421 sequence, right? Which we saw a couple of times in a previous video. So why don't we do a collat sequence that stops when you hit 1. Okay, so if we do that, let's see here. I'm going to just give it a seed. So I'm going to say x is 13, not 134, 13. I'm going to say while x is not equal to 1. Now notice I'm not sending in a list this time. I'm just saying, hey, I'm just going to keep rewriting the collat's terms. So I'm going to print my x outside of this. So while x is not 1, now I need to check if x divided by 2 gives me a 0 remainder. So in other words, if x is even, x is equal to x divided by 2, print x. Otherwise, x is equal to 3 times x plus 1, print x. So I should stop when I hit 1. 13, 4, 20, 10, 5, 16, 4, or I'm sorry, 16, 8, 4, 2, 1, boom, stopped. The very next, so the time when it hit a 1, so it got down to a 2. 2 is even. It took it divided by 2, printed it, came back up here and says, okay, x does not equal 1. So does 1 not equal to 1? Well, that's false. So it will not enter the loop anymore. And I can check that over here. I'm going to go over to a scratch cell. If I just look at x, print x, right, it is 1. Print x does not equal 1, and it says false. So there's a cool way to do the collat sequence. It's actually a lot cleaner because it will always end. Now I can do like 58, and I can see the whole sequence until it hits 1. I can do 580, and now it does the whole sequence. Holy bananas, it does the whole sequence. Look at that, 421 right there at the end. Okay, so this collection of 3 videos has done for loops, if statements, and while loops. These are really handy programming tools that let you do repetitive tasks really efficiently. See ya.